All right, let's begin the state of matter phase change lab. The overview, you are going to expose an H2O molecule, water, to thermal energy and measure the temperature as the water transitions through the states of matter, solid to liquid, liquid to gas, as well as making observations. Now, I cannot overemphasize how important safety is. You'll notice I'm wearing the safety apron, and at all times, I will be wearing my goggles. Now, there are several other safety features that are unique to this experiment. You will notice the HP 155 hot plate, which can get as hot as 250 degrees Celsius. That's almost 500 degrees Fahrenheit. You will notice we have taped off a danger zone. Unless you are wearing a heat-resistant glove, you do not let anything, body part, pencil, penetrate this area to get near this heater. This heater will get extremely hot. That heat will rise, as will any steam, heated gases, so you do not look over the top of the experiment. There's also a chance of fire danger. So we will have reviewed the fire safety, the most important safety feature. If something happens, notify your teacher. Don't raise your hand and wait. Say, hey, Mr. Nicewander, Mr. Pekar, something has gone wrong. Be mindful of your cord. The cord is connected. You do not want to pull it. It should be secure. But if you trip over it, it could pull your burner outside of your safety zone. So if we treat it with respect, it will provide us with the thermal energy we need. Let's start with the procedure. First, I want to take and empty in approximately 400 milliliters of solid H2O. We know it as ice. You will get a zero minute starting temperature in Celsius. And you will record every minute the temperature in Celsius. You will also record what state of matter is present and any other observations. Let's begin. I will put it on the heater. The heater is not turned on yet. And another important safety feature, when you come in, if you have had a period before you, their heater may still be hot. So mindful of this safety zone. So I take my 0 minute reading. I stick the thermometer, the red bulb, down into the substances. Oh, I see it moving. It's dropping. So the solid H2O is colder or has less energy than the room air. And it is reading -2 degrees Celsius. So write down for your 0 minute, -2 degrees Celsius, and it is a solid. I will now place the solid in the actual lab. Your teacher will energize the heater. I now start looking at my timer. It is now going into the first minute. Now, another safety statement is it is exceedingly easy to become distracted while you're waiting. So you want to watch it, and as I look at the bottom, I already see it looks like some of the ice might be melting. You do not want to ever turn your back on the heater. You do not want to get distracted by talking to another group. You always want to have your eyes on the experiment. Now, the heater does not instantly turn up to 500 degrees Fahrenheit or 250 degrees Celsius, but it does get hot gradually, and you'll feel it. Oh, we're at 4, 3, 2, 1. I put it in the middle, and I give it a chance to react. I don't instantly take what it is, and it's going down, and I have 0 degrees Celsius. It's bottomed out at 0 degrees Celsius. So for minute 1, 0 degrees Celsius, I see some, don't want to bring my hand in there. I see some liquid and some solid. So for state of matter, liquid and solid. Meanwhile, 40 seconds has gone by while we did that. So we are already approaching our 2 minute time period. 3, 2, 1, 0. And the thermometer was at room temperature. So once again, it is dropping down, stabilizing at 0 degrees Celsius. I still have liquid. I still have solid. So for 2 minutes, 0 degrees Celsius, liquid and solid. Now, if you choose, you may have another individual switch off gloves, but if you are entering in the safety zone, you must have the heat resistant glove. 6, 5, 4, 3, 2, 1, measure. Right down there in the middle, and I'm shifting it a little bit, so I want to be gentle. I don't want to knock this off the heater. If I did, I would immediately tell the teacher. And once again, I have it at 0 degrees Celsius. I have liquid and solid present, and I can hear something, but I'm not sure what that is. It's the littlest bit of sizzling. I don't see any bubbles being created. So I'm just going to write that down. And the amount of liquid is increasing. Now I'm coming up on 4 minutes. This goes faster than you would think. 3, 2, 1. Once again, I take my reading. I want it to stay in the middle. But now there's some water touching it. I wonder if that will make a difference. And apparently it does not. Still 0 degrees Celsius. 4 minutes, 0 degrees Celsius. I have water, liquid, and solid. I do not see any evidence of gas yet. All right, coming up on 10 seconds to minute 5. 4, 3, 2, 1. Minute 5. Oh, the thermometer is definitely in the water. There's ice all around it, as in solid H2O. Let's see if that makes a difference. Nope, it lowers to 0 degrees Celsius, hangs out there. I'd say there's almost as much liquid as there is solid in there. But at 5 minutes, 0 degrees Celsius, solid and liquid. Now, if you do decide to change partners on measuring, you want to do it right after the temperature's been measured because you want to make sure you stay on track. All right, coming up on 6 minutes. 6 minutes, and I can even see a little bit of heat ripples around this heater, and I can smell it. 3, 2, 1. 6 minutes. There's now more liquid than solid, but it's still at 0 degrees Celsius. How interesting. Yep, 0 degrees Celsius for 6 minutes. Now I notice on the outside there's a little bit of water condensation, so the water vapor in the air is hitting the cold, the substance, liquid and solid, is still 0 degrees Celsius, and there's a little bit of condensation on the outside. I'm surprised by that. All right, coming up on 7 minutes. 7 minutes. 4, 3, 2, 1. Going back in. Definitely more liquid than solid. Still 0 degrees Celsius. How interesting. So, minute 7. 0 degrees Celsius, liquid and solid. And if you get worried, you smell a burning smell, certainly you can look down in there. If you see any smoke, you would want to call your teacher. A burning smell, you can call them over. These heaters are older than you are, so when in doubt, call the teacher. All right, coming up on minute 8, 2, 1. Minute 8, and I definitely can feel the heat coming up to my glove. I do not want the thermometer to touch the glass on the bottom because then it would be directly getting heat from the heat plate. Now what I find so interesting is I can feel the heat coming off this heat plate. It must be close to 150, 200 degrees Celsius, yet the H2O, even though it's mostly liquid, is still showing 0 degrees Celsius. Where is all that energy going? Interesting. 0 degrees, minute 8, 0 degrees Celsius. Coming up on minute 9. Now I'm looking in there. Ooh, shouldn't look over the top. Mr. Picard, pay attention. I see that almost all of my solid is melted. All right, 2, 1, minute 9. I'm getting the slightest little bit. I'm going to say 2 degrees Celsius. So there's a little bit of movement. However, I can feel so much heat energy coming off of this hot plate. So there's still a little bit of solid in there. So for minute 9, 2 degrees Celsius. You could even put a little bit of solid. It is mostly liquid H2O. Coming up on minute 10. 3, 2, 1. Putting it in. Oh, it touched the bottom of the beaker. I don't want it to do that, so I put it in the middle. And it's reading about 4 degrees Celsius. 4 degrees Celsius. So it's going up just the slightest amount, but I can feel so much heat energy coming out of that burner. So for minute 10, 4 degrees Celsius. Oh, the littlest bit of solid still left in there. Minute 11, 4, 3, 2, 1. Minute 11, and I see no solid left there. And whoa, we're up to 12 degrees Celsius. 12 degrees Celsius, only liquid. Now the temperature jumped in 1 minute, 6 degrees Celsius. Minute 12. 3, 2, 1. In the middle, I'm not touching the bottom. Whoa, it's going up. It's still going up. Wow, it's really going up now. 24 degrees Celsius. Coming up on minute 13. See any evidence of gas? No, I see the liquid seems to be churning about in there. 3, 2, 1. Minute 13, it is completely liquid. Still going up. We're up to 35. Minute 13, 35, all liquid. And if you look, you can see the water, any of the particles in the liquid is churning around. There's all this heat causing it to move. All right, coming up on minute 14. 3, 2, 1. Minute 14. Let's see what we get. Wow, that's crazy. It's flying up there. Still going up. It looks like 46. So, minute 14. 46 degrees Celsius.